Hello, students, boys, girls, parents, and the guardians at large. We are back into our business of maths, right? We have had a lot in the discussion. That's book 3, as it is. I'll urge you to revise the videos, the previous one, by the link down here. More especially, the one we have introduced a new topic about the transformation, so that what we're going to talk today should be meaningful and be logically followed. So please do that. More special again to those who have not been with us since we have introduced this new topic about the transformation. This is the 8th topic. Without wasting much of your time, let me just have an intro of it before we look into what we are going to discuss this moment in time, this video. We define transformation, and we say transformation is just an issue that is related to change. So in this case, we are looking at how an object can change. An object in our study, we are referring to any figure. It can be a triangle, it can be whatever polygonal shape. That's it. If that one can change in terms of position, in terms of talk of shape, in terms of again of what? Size. These 3 terminologies define transformation. So an object can change in terms of position, in terms of shape, in terms of size. That's it. So here, basically, we are focusing in 3 ways on how an object can change in any one of 3 definitions. That's one, the one which we have already been looked into in the previous video, that's by talk of the translation, to say an object can translate or a figure can translate. So we have discussed issues which are required for you to translate an object or talk of a figure. It's by the previous video that we had. You can be able to be connected there if you need to translate an object. That now we define issue about what? Change of a position. Right, so please can you go through that one and understand how an object can be translated. So this is the first way how we can transform an object or a figure. Secondly, we talked of issue about the rotation, that this is another way how an object or a figure can be transformed. So today we'll be looking at the rotation at large. Lastly, it is an issue about the enlargement. Right. So this is the last way which we are going to discuss here in transformation. So we are talking of the 3 ways how an object can transform. One, by translation. Second, they talk of rotation. Last, they talk of what? Enlargement. So these 3 things are the ones that will be able to make an object either to change a position or to change the size or shape. Right. So if the object is tampered in this way, you'll be able to see it. Either you change the position, the size, and what? And the shape. Right. So now, without talking too much, more we already discussed in the first way how an object can transform. Let us get into the second way how an object can transform. Right. So this is by rotation. So allow me to remove this title and the subject which was written on top in order to have enough space. So here we'll talk of the second way, that is rotation. Right. We talk on object is being rotated. Transformation by rotation. What are the issues, first of all, that we need to consider before we start looking at the way we can rotate an object? Because you need to do that, it's more like an activity. You need to know how best you can rotate an object. Right, so first of all, let us understand what is it that we need to know about rotation. Right, one, if a figure, be it a triangle, whatever you have, you rotate, you need to be able to know that whatever is there, the action does not incur issues about the change of size, change of shape. The way it is, the object it is, the resultant object coming after that rotation, you could know it is the image, that one will be exact. It will be the same as the object itself. Because as we said, say for example, I've got a triangle here. If this one has been transformed, we need to have another figure here. So the result of this transformation gives what is known as the image. But this one now is the object, any figure you can have. So here in rotation, what happens is just like when you are going to transform this object, in this case it's a triangle, by that is now rotation, the result it will be an image. What we will be able to see here or observe is that the image here will be the same, like what? That's the object. To mean to say that the image will be congruent, maybe another way around, we can say it, with the what? That of the object. So image that we have will always be congruent. Congruent to the talk of the what? Object. That's the initial figure, initial figure. And also, we need also to consider that, say, the shape and the size of the image will be the same as the what? As the object. So it means just like somehow, somewhat, what changes here in the rotation is only more like a position of that object. Nothing is affected in terms of what? Size and also shape. So that's why we're talking of the image is always congruent to the what? Object. Because the initial object is the same as the resultant object after transformation. Right. Those are a few things that we need to know about the nature of the image after what? That's a rotation. Now, when now it comes into issues about rotations, what are the points to consider when we are rotating an object? Because you'll be asked even in exam, rotate an object. So what is it that you as a student, you need to always consider each time you talk about rotation? So here I will discuss with you some points to consider if the time we talk about rotation. So here we are, points to consider when we are rotating a figure. In the rotation, we need to consider issue about the one, angle of rotation. Right, an angle of rotation. Meaning to say, a figure, once it is rotated, there's always an angle that has to be defined. Without an angle of rotation, we don't expect the figure to transform by that. Rotation will always anchor an angle. For example, here with me, I've got a protractor. Can be fixed at one point here, like this. Look at the way how fixed up my protractor at this point. Let's consider that this one is fixed at this position O. Now, if you can consider this part of the top of the protractor, and I can produce a line, something that looks something like this, you'll be able to see when I talk of rotating, it means I have to more like spin this protractor. So if I rotate, either with my light, it will be an issue something like this one, rotating about, or it will go something like this each time I move like that. So can you look at the new position of this side, which was in relation to that line? You find that after I've rotated this one to a certain level, you find that that original line, which is defining the side of this protractor, will be somewhere here, and I can draw it this way. Look at this. The protractor originally was at this position, heading against this line here. If I spin a little bit for some distance, it found that this one will move like that up to this level. So if I stop here, it means just that this line representing this side of the protractor will be somewhere here. So if I'm going to draw the that line representing this protractor, it will be here. So now if you can look at what has happened here, as I was moving this protractor to this level, you'll be able to see that as I spin this one like that, there's an angle of some kind that is being created. And this angle is this one here. So this angle is the one that is defined as what? Angle of rotation. The more you spin this protractor, it means the more angle that is what? Being created. And that angle is always related to what? 360 degrees. So it's more like you are picking part of the 360 degrees that's defined about, that defines the what? Angle of rotation of a particular figure. So whatever you do, you rotate a particular figure, whatever you can have, talk of a triangle, talk of a rectangle, etc. There must be an angle of some kind that is at least guiding the movement of an object in the rotation process. So that's it what you do here. So if you talk of angle of rotation, this is just a good example which I've just given you here. You can be able to see that an angle is being created. So you can measure that angle, you'll be able to pick up, it can be whatsoever, maybe 120 degrees or whatsoever. Right, you can also use the same protractor side. So it means the first point to consider if we talk of issue about the rotation is the angle of rotation. So it means be there at least using such issues whenever we need to rotate a particular figure. Right. Secondly, apart from the angle of rotation, which is very paramount, we need also to consider issue about the center of rotation. Right. Center of rotation is just like that point about which that figure is rotating, a fixed position as such. Like for example, if I come back to demonstrate my activity, which I had earlier, you'd see that if this protractor is fixed at this position, if it is rotating, I don't think this one has to leave this end, that point, right? So for example, here I've got my line representing this side of that protractor. I move like this. If find that this protractor is moving or spinning about this point here, let me still modify this one as point O, right? So whatever direction, or either maybe I go toward this direction like this one, it is still more that same position. So in this case, our point O, this one here, is the one that is defining what? That's the center of rotation. This is the center of rotation. And with it, you can be able to create what is known as the what? Angle of rotation. Look at this one. This is the angle of rotation. Right. So it means angle of rotation and the center of rotation are just like working together. They're just like together. You talk of angle of rotation will be there only when you have got the center of rotation. Center will be there, also be able to affect the what? The angle of rotation. So center is just like a point at which the object is turning or is rotating. In this case, in this activity, we can realize that the protractor was turning about O. So O is considered as the center of rotation. So let's know angle of rotation, center of rotation, very important issues to be known each time we consider issue about rotation. The third one is the direction of rotation. Right, direction of rotation. Still more in the same activity, simple one. When you rotate an object, just like there must be a direction of some kind. To which side are you rotating an object? So here the direction are described in only two ways. One, an object can rotate in the clockwise direction. Or else it can rotate in the anti-clockwise direction. Other student, please try to pick up. When they say an object is rotating in the clockwise direction and then anti-clockwise direction, these movements will always affect the what? Angle of rotation. So it means just like the angle of rotation will be able to tell you the direction of the rotation, because if something is moving, there must be an angle that is created, right? So if I've got a particular angle of rotation, that will be able to define which direction an object is rotating, right? So an object can rotate in either of the two ways, clockwise or anti-clockwise. So here, let us also demonstrate. When you say an object is rotating clockwise, and what will be the nature of the angle of rotation. And again, when we talk of an object is rotating anti-clockwise, then you need also to know what will be the nature of the angle of rotation. Right. So allow me again to have another activity with the same protractor so that you can be able to understand the two issues about clockwise and anti-clockwise in relation to the angles of rotation. Right. So here we are. I'll have my point here. I'll regard this one as my center of rotation. It's a fixed point, that one, or light. So what I'll have here is this. Let me also lay that one out. So if you can look at this one, considering this side will be represented by this line, right? So that is my starting, that is my line, that is the describing of the entire word protractor. So if I will need to rotate this one, I can either rotate in the clockwise direction. You can understand the clockwise direction by how the clock itself behaves. Look at the talk of the minute hand, how they move towards the light like this. So in this case, we talk of this one, protractor moving towards the light like this. If this one is moving towards this direction or you move to the light, that is a clockwise direction. And that's the way the minute hand of the clock moves. Light. So you see that if this one is moving to the light like this, that is clockwise direction. But now if I tend to move this protractor to my left like this, that is now just like the opposite. That is now anti-clockwise. Look at that. So each time I'm moving this one from the original line, which is this one here, you'd see that if I'm moving to the left like this, an angle is created against that line, but about a fixed point O. So if I move like this, it means the angle that is created is this one here. Look at this. So this angle is being created like that. I'm moving to the this is clockwise, right? But if I move like this from this line, I move towards this way, that is now clockwise direction, right? So also here, an angle is also created. So it's either you can move your protractor this way and the line is there, or from this original line, you can move it this way. So you find that the line comes here. So from this, you'll be able to see that object has moved from this line, heading towards this direction, up this position, an angle has been created. I can take this one as theta, but this side here, there's also an angle which has also been created. Right, so if these are equal angles, we can have toward this direction for the anti, this is also theta, but the way they move are different in terms of direction, clockwise and clockwise. So if it moves on the clockwise direction, the angle in this case, the angle is always bearing a negative. So when you go to this side, the angle of rotation is negative. But if you go to the anti-clockwise, the angle here is what? Is positive. So every time you talk of the angle of rotation is defined in negative. Just know for sure that that object is rotating towards the what? Clockwise direction. That is to your right hand side. So talk of the angle of rotation can be negative 60 degrees, negative 40 degrees, negative 180 degrees. It depends the way that object can rotate. Right. But now if you talk of issues about the anti-clockwise, it means the opposite for these ones is true. Instead of having 180, the object means can rotate 100 and what? 80 degrees. This is positive. And again, instead of having 60, negative 60, we have now 60 degrees. This is positive. And then somewhere we have got 40 degrees. That is also positive. So this defines the anti-clockwise direction, but these ones define the clockwise direction. So, of course, some students might be able to say, but now, this is the positive side. Yes, looks the positive, but that is negative in this case. But the talk of this way is the left-hand side we expect to be negative. No, that is the positive. Right. So, angle of rotation can be negative or positive. For the positive, it means it is telling us that the figure is rotating towards the what? Negative side. If it is negative, that one tells us that the figure is rotating towards the what? Positive side. Right. The next that we need now to do is just an action itself, whereby we need to try and rotate an object. Right. So let us have this example. Suppose if we are given a triangle like this one here, we are given a triangle. Okay, let me draw it here, just right at the middle. Right, let's consider that this is triangle A, B, C. Slight angle at B. Right here, we've got the center of rotation. Let's have it here. You might be asked a question like here, this is center O, right? That's a fixed point. Our question here that we need to do is would like to rotate this object and see to what position would it be. Right, we have got triangle A, B, C given here, and here we are asked to locate the image of this. That's now the result of transformation. Right, so considering those points we have had, we are here given the angle of rotation to be 60 degrees. Let us have the angle of rotation being 60 degrees. This is the angle of rotation being equal to 60 degrees. How do we rotate an object about an angle of 60 degrees? Right. At point what? O. So here it means our O can be considered as the center of rotation, and this angle is 60 degrees. What would be the image like, and at what position would it be? Right. Now, if we want to rotate an object or a figure with a particular angle, you need also first of all to realize to say which direction are we going to head. In this case, how is this going to rotate? Is it towards the right or to the left? Right. So by what I explained earlier, you look at the nature of the angle given. Like here is 60. This one is a positive one. Then understand from it that say the direction of the rotation in this case must be what? That say towards the anti-clockwise direction. That is now to your left side. So whatever you do here, whatever we're going to do here, you should be able to see that this object is rotating towards the left side. And this is the way it has to be created. Like here, this is my center. The image must be towards the side. Had it been this one would have been negative, then our object would have been found towards that side. Right, so this is going to be rotated towards the anti-clockwise direction because the angle is positive. Now, what are the issues that we need to consider in rotating this figure and or other figures of concern? One, what you need to do is an issue of, you have to take me light here. I may not light all the points because of the space. First point, in case you forget, you can play the video now and again and master the concept. You can even write on the paper. First step is to consider the vertices of that figure you have. This figure has got point A, B, and C, right? So what you'll be doing is you are going to connect those vertices one at a time to point O, which is regarded as your center of rotation. Take that one light. Connecting these vertices one at a time to O, which is the center of rotation. So let me demonstrate that one out. I'll begin with C. So I have my C here connected like this. This line here, to me, I define it as an object line. It is connecting the object, one vertex of the what? Object. This is an object already, right? To the center of rotation. This will be just like a center of rotation because this one will be spinning around this, and it's where an angle is going to be created. Right. Now, next, it's like when this one is rotated, what will be the new position of C? That one now would be the image of what? Of C. Because once this one is rotated, we don't expect this to be at the same position. It should be somewhere. So the moment you have joined connected C to O, what you do is you take now a protractor like this one here. You come and fix it at that position. That is your center, right? I may not be accurate exact here because you cannot look at my nature of protractor and also the board. Things are not yet drawn to scale, but I know where you are. You can do much better. What is here, get the skills, underlining which. So here, look at this. I put my protractor here to at least obtain an angle of 60 degrees. So my protractor will be put like this. But if it were to be negative, my protractor would have faced downwards like that one. So that I have to make sure that the shape has to be rotated toward the light. But this is positive. Then now my protractor has to move like this so that the entire object has to be rotated upwards. 60 degrees. My 60 degrees is here. So I'll make a mark like this one here. Like that. This is my mark. A line from here up to that is 60 degrees like that. Right? Now, after I've made the mark like that, what do? I will then remove my protractor, put it down, and then try to take note of the distance from here up that. This is object distance. The object distance must always be the same as what? The image distance. The image distance, we talk of the distance from the center to the image of C. That is the distance. Image distance. So here, if I'm talking of being the same, it means to come up with the position of C, what I need to do is I have to make the distance from here up to that. So the distance from here up to that should be the same as distance of the image from the center. So here, I'll do like this. Oh, how long is this one? I'll have it like this one. Look at this, look at this. So here, it is somewhere here. Whatever you can have on the ruler, is it 5 centimeters, 10 centimeters, and what have you. So this distance is the one that has been inserted here. You bring it here close and towards that point of the 60 degrees. This is a mark of 60. So what I'll do, I'll draw a line from there. It goes up, passing through that point here, up to that level, like this. So you can have this line here, like that, up to that. So let me also have this one as dotted, like this one here. It begins from here. It goes like this one. Right. So distance from here up to that is the distance from here up to that. So it means my C is here. So this is the C complement. This angle here is 60 degrees. That is 60 degrees. Right. So what we have done here should also be done to the remaining points. So which means for B, I'll also do the same. I'll have to consider a line first, which is the object distance. So from the first where we have got a C and C prime, this is the object line, this is the image line. Right. So object line for point B, it will be this one here. I connect it from B to center O like this. Look at that. Then after, what do? I'll take my protractor, the same activity I did area for C. So I have my protractor here again. Don't put it downwards, but upwards like this. Look at this, look at this, look at this, look at that. Right. What is the angle? 60 degrees. I'll come here. What will it be like? I'll also check. 60 degrees is here. So I also make a mark here. Look at this using a protractor. Right. So which means whatever line will pass through this against that line, it means an angle so formed is 60 degrees. So what do? I'll take the measurements of this line here. Objective distance. How long is it? So I have my ruler placed here from the starting point, that's the center, up to that position of B, which is this one here. Look at that. That position there. So that should give us the exact line for this one here. So it means I'll come here and draw my line up that level like that. So that will give me the new position of that is B. So B must be here. So I understand this one B prime. Look at that. So if you can measure the angle between this line, object distance, And the image distance of B, you find that this is also 60 degrees, this one is also 60 degrees. But in this case, there's no need for you to indicate the 60 degrees light. Now, we also do for A. What is A? A is that position. Of course, it's an object, a vertex. Let us consider what is the line, object line for it. So also do as we have done with B and C. So I also have a line from A to center, which is O, this one here. So this is object line, object line, object line, this object line. This is object line, this object line, image line, this image line. So the distance here from here up to that is this one here. So now, a new position of A, that's the image. I also take my protractor and do the same. So protractor will be on top of that line and bring it like this. Light. So 60 degrees, you read out like that. That is now 10, 20, 30, 40, 50, 60. Your position of 60 will be somewhere here. Light. Then what do? You also have to measure the distance from A to O, which is what? In this case, according to my ruler, I can even use a pair of divider. Right? It's this one here, up that. So I'll take that one and come towards that mark of mine. So this one, it tells me that the position must be here. So this is the position of A. So my A is here. A prime. Then I connect the points, that one with this one like this. So what I'll have is what? Is this line like that. Right. Now at the very end, what are we going to do? We connect all the points with what? Prime. So it means I will have my B and A prime connected to form a line like this. So this line here, AB prime, is the image of AB as your object. And here, then we're going to connect with AC like this. Look at this. So we have something like that. Then finally, I'll connect A and C. I have something that looks more like this. Right. Look here. We have got this one here. Like that. So that's it. If that is 90, so our 90 is here, the same exact angle. So this is your image. This is our object. Right. So please, my students, can you try to go through, pray now and again this video, be able at least to be familiar. Because what I've just talked here can be repeated if you keep on praying the video until you grip up the concepts. So this is the way we rotate an object. So the object here has rotated towards the clockwise, the anti-clockwise. This is anti-clockwise because the angle here is 60 degrees. So this one has been rotated at an angle of 60 degrees. Center of rotation is the center O. Center over rotation. So please revise. What comes does not repeat the drum can have a question about rotation here. Right. So at the moment, that is all that we had. So we have another example in the next video where we have to see this activity be performed on the Cartesian plane. Suppose they'll give you the graph paper and they'll ask you maybe to draw a particular figure given the points with their coordinates, and they'll ask you to rotate that. How do we do that? Right, so at the moment, can we stop here and be able to appreciate what we have done? We have just known what a rotation is all about as an example of the transformation and what is involved. Right, thank you very much. Ask your friends to be connected by the videos we have here. The link is down here so that we have to all be updated. Thank you.